Hello, welcome all. Myself Kiran. I am from Department of SVCC. Today we will learn about phases of compiler design, which is a concept in automata theory and compiler design. First, let's see why use a compiler. All compilers only understand machine language. That is, machine language is nothing but a series of or sequence of zeros and ones. Okay, and therefore high-level instructions must be translated into machine language prior to execution. That is, in order to make our task or our programs understood to the computer, we need to convert high-level language to low-level language. So we use compiler. Okay, that is the use of a compiler. And let us see compiler. A compiler is a large program that can read a program in one language, the source language, and translate it into equivalent program in another language, the target language. Okay, that is, let us assume the source language as C, C++, Java, etc. Okay, and the target language is always the same, that is machine language. Machine language is nothing but sequence of zeros and ones. Okay, and important role of the compiler is to report any errors in the source program that detects during the translation process. Okay, when you write a code in the code editor and when you compile it, the job of the compiler is to check the errors, so that if there are any errors, it will be telling to the user so that user can correct it accordingly. Okay, here I had given a simple diagram how the compiler is. Okay, source program is given to the compiler and the compiler will convert it into target program. Okay, and if the target program is executable machine language program, it can be called by the user to process inputs and produce outputs. Okay, and let us see one simple example. I had given a code. Okay, source code. Okay, and this is converted to target code. As I told you in the previous slides, the source code is nothing but sequence of zeros and ones, that is machine language. And see interpreter. An interpreter is another common kind of language processor. Instead of producing a target program as a transaction, the interpreter appears to directly execute the operation specified in the source program or input specified by the user. Okay, and the machine language target program produced by the compiler is usually much faster than the interpreter as mapping inputs to outputs. Okay, I will tell it in simple words. Interpreter is nothing but it's also one of the kind of translator where it converts the source code into machine code. Okay, and the only disadvantage of this is the time it takes to produce the machine code is a little bit more when compared to compiler. Okay, and let us see working process of compiler versus interpreter. First, the source program is given to the compiler and object program is produced, and then the executable computer will take the data and the result is produced. Okay, this is the compiler process or the compiler works. And let us see the interpreter. The source program is given to the interpreter and required data, that is the input, is given. According to that, the result is produced. This is the simple working of the compiler and interpreter. And let us see the interpreter and compiler difference. Compiler takes entire program as inputs, whereas interpreters take single instructions as input. Okay, and immediate object code is generated. No immediate object code is generated in the interpreter, and in the compiler, conditional control statements are executes faster, and in the interpreter, conditional control statements are execute slower. Okay, and memory requirements. More object code is generated. Memory requirements is low. Okay, and the program need not to be compiled every time. Every time highest level program is converted into lower level program in the interpreter. Okay, and errors are displayed after entire program is checked in the compiler, and errors are displayed for every instruction interpreted in the interpreter. Example for compile program languages are C, C++, okay, and interpreted programming languages like Python and Ruby. And I will tell it in simple words. Compiler it executes the whole code. Okay, and interpreter it executes line by line. That's the main difference of the compiler and interpreter. Okay, and let us see the phases of the compiler design. A compiler operates in a phase. A phase is logically interpreted operation that takes a source program in one representation and produces an output in another representation. The phases of the compiler is shown below. Two phases of compilation: analysis and synthesis. Compilation process is partitioned into number of sub processes called phases. Okay, let us see. You can see the diagram. Okay, just see it, and I will going to explain it in the further slides. Okay, just have a look at it. Okay, and let us see the first phase, lexical analysis. Lexical analyzer reads the stream of characters making up the source program and groups the characters into meaningful source called lexeme. That is, lexical analyzer job is to group these characters and make the sequence called a lexeme. Okay, for each lexeme, a lexical analyzer produces a token of form that is that that it passes on to the subsequent phases, syntax and analysis. Okay, token name comma attribute value, and token name is nothing but an abstract symbol is used during the syntax analysis, and attribute value points to an entry in the symbol table for this token. And see the syntax analysis, also called parsing. Okay, and parser uses the first components of the tokens produced by the lexical analyzer to create a tree like intermediate representation that depicts the grammatical structure of the token stream. A typical representation is a syntax tree in which each interior node represents an operation and children of the node represent the argument of the operation. And semantic analysis. Semantic analyzer uses the syntax tree and information in the symbol table to check the source program for the semantic consistency with language definition, and gathers the type of the information and saves it in either syntax tree or symbol tree for subsequent during the indeterminate code generation. And an important part of the semantic analysis is type of checking, where the compiler checks that each operator has matching operands. Okay, and see the intermediate code generation. After syntax and semantic analysis of the source program, many compilers generate an explicit low level or machine like intermediate representation. This intermediate representation should has two properties. It should be easy to produce and it should be easy to translate into target machine. The, the considered intermediate for form called 3 address code, which consists of a sequence of assembly like instructions with 3 operands per instruction. Each operand is like a register. Okay, and see the code optimization. A compiler looks at large segments of the program to decide how to improve the performance. A machine independent code optimization phases attempts to improve the intermediate code so that better target code will result. Usually better means faster, shorter and target code that consumes less power. There are simple optimizations that significantly improve the running time of the target program without slowing down the compilation too much. Optimization cannot make an inefficient algorithm efficient, only makes an efficient algorithm more efficient. And the last phase is the code generation. The last phase of translation is code generation. Takes an takes as input an intermediate representation of the source program and maps it into target language. If the target language is a machine code, registers or memory locations are selected for each of the variables used by the program. Then the intermediate instructions are translated into sequence of machine instructions to perform a same task. And the crucial aspect of the code generation is to judicious assignment of the registers to hold the variables. And thank you. If you have any doubts, feel free to write the comment in the comment box. I will be there to assist you. Thank you. Have a nice day.